Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity. Today, we will dive deeper into the roles of field devices, field controllers, and human-machine interfaces, HMIs. Field devices are crucial in industry control system, serving as the interface between the ICS and physical processes by collecting data and controlling actions. Let's explore the types of field devices, starting with input devices. Sensors and transmitters collect and transmit data for processing and control. Discrete input sensors measure binary events, such as a tank being full or a door being closed. Analog input sensors measure continuous processes like flow, level, and pressure and transmit information using analog signals. Digital input sensors, on the other hand, measure continuous processes and support binary events using digital communication protocols. Moving on to output devices. Discrete output devices are binary devices such circuit breakers that perform actions based on control signals. Analog output devices control actuators, valves, and motors using varying electrical signals. Lastly, digital output devices control voltage with computers for quick and reliable communication, useful in alarms, fans, and lights. Let's look at some examples of field devices. These include meters, sensors, valves, and switches, each playing a vital role in the functionality of industrial control systems. Field controllers process input-output data and communicate between field devices and human-machine interfaces, or HMIs. These devices are ruggedized, embedded microprocessor devices designed to withstand harsh industrial environments. Let's look at some examples of field controllers. First, the Programmable Logic Controller, or PLC, automates processes and functions, and was initially developed for the automotive industry to replace hardwired relay systems. PLCs use programming languages such as ladder logic, structured text, and function block diagrams. Next, Programmable Automation Controllers, or PACs, are suited for complex automation systems, offering greater flexibility and better handling of analog input-output. PACs feature open architecture, a modular design and communication capabilities via Ethernet, OPC and SQL. Remote terminal units, or RTUs, interface with objects in the physical world, transmitting telemetry data and controlling connected objects typically used in utilities and industries with geographically dispersed facilities. Lastly, Intelligent Electronic Devices, or IEDs, are controllers for power system equipment in the energy sector, monitoring and controlling electrical devices. However, their default configurations and active communication ports pose cybersecurity risks. Human-machine interfaces, or HMIs, are workstations that provide graphical interfaces for operators to monitor and control processes. They offer real-time views, historical trends, alarms, and notifications. However, the use of standard operating systems and remote access increases the risk of cyber attacks. If compromised, HMIs could allow attackers to control critical processes, highlighting the importance of securing these interfaces. Associated with HMIs are several key components. Workstations serve as interfaces for monitoring and control. The SCADA server facilitates communication between field devices and controllers. The Emergency Management System, or EMS, optimizes energy use within the industrial control systems. Understanding the functions and security concerns of these components is vital for maintaining efficient and secure industrial systems. Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.